Okay guys, let's take a look at today's lesson. We're going to be looking at functions defined by integrals. This is basically a continuation of what we did yesterday. We first started talking about functions defined by integrals yesterday with our accumulation function. So this, if you'll remember, this portion right here, as we looked at yesterday, is actually the derivative of f of x. So this would be, f prime is what that is, just to remind you. This number right here indicates where we would start integrating to determine y values. That indicates y values. I have had a lot of confusion actually today with the use of this number. This number adjusts the y value. It does not change the derivative, how the derivative is comprised. If the derivative is above the x-axis, like in a graph, it's still above the x-axis. It still shows increasing if it's above the x-axis. This simply affects the y values that you will find from this expression. And you'll see some like that in the daily work. So this particular question asks us, for what values of x is the graph of f decreasing? Well, going back to our knowledge of calculus, how do we find increase, decrease of a function? We take the derivative, we set it equal to 0, we do a sign chart, right? That's what we do. And this actually is the derivative right here. We've identified the relationship between the integrand and what it equals. So this is the derivative. So what we're going to do is we're going to take the derivative and we're going to set it equal to 0. We do a sign chart. So that's -2 and 3. Testing our signs, we should get negative, positive, positive. All right. So now let's go back and see what they're wanting again. So we want to know where f is decreasing. Please note that this is signifying this. Very specific about how they name things. It will be named accurately, so you need to pay attention to the name. So where is f decreasing? It's decreasing when the interval is negative, right? That's some review. So from negative infinity to -2, because, so it's decreasing, because why? Yep, because f prime of x is less than 0. Okay? That's our standard justification that we've been doing for weeks now. All right, that's number 1. We okay? All right, the second one, a little bit unusual. So notice that on number 1, we added in an equation. Yesterday we were basically working with graphs, different graphs that depicted the derivative. Today we're adding some equations in and some more abstract concepts with this. So let's look at number 2. We're given this kind of strange looking equation. We're told that 3x squared minus 12 is equal to the integral from c to x of f of t dt, and they're asking us to find f of x. Okay. So how do we get to f of x? What has to happen to the integral? It has to go away. And how do we make the integral go away? Derivative. What you do to one side, you have to do to the other side. Right? You with the logic? We're going to have to take the derivative of both sides in order to lift the integral so we can get to f of x. So let's write that out. So d dx d dx c to x f of t dt. Okay, so that's our setup. What we do to one side, we have to do to the other. And we learned yesterday when we take the derivative of the integral, and there's a constant in the lower bound, x in the upper bound, this turns into f of x. That was a rule that we worked on yesterday. All right, that's a rule. And we went through and looked to see why that was so and how that's accurate. And on the left side, we need to actually just do the derivative. So that would be 6x. So now we know that f of x is 6x. Okay? The last part B says find the value of c. They're talking about this. Okay, let's write out the equation. 3x squared minus 12 equals integral c to x of, let's see, we already know f of x, so do we know f of t? We do, right? If f of x is 6x, what's f of t? 6t. So 6t dt. All right. So the right side, we can do the integration there. Right, the left side, we're really not sure what's going on there. We're just going to have to leave that alone for the moment. But we can do the integration on the right side, so let's do that. So we'll leave the left side alone. So the integral of 6t, the antiderivative of that would be, what, 3t squared, and then evaluate it from c to x. Okay, so let's keep going with that train of thought. Let's do our evaluation. The f of b minus f of a. So I put the b in, and I get 3x squared minus, I put the a in, which is c, 3c squared. Okay? So at this point, you probably notice that the 3x squareds are going to net out. They're going to go away. So I'm left with negative 12 equals negative 3c squared. So I divide the negative 3 off, and I get c equals plus or minus 2. Now we just need to verify that that's okay, that would be an accurate statement. And so if we tried down here, certainly they would both work. They would both work. So now we found c. Okay? We okay?